day. This is the Professor, CBMD PhD, and today is Wednesday, August 30th, 2023. It is 8:16 and 23 seconds, p.m. Eastern Standard Time, and today's research, quantum sensors. So let's to it here. As paving the way for advanced quantum sensors, new study explores finite range interactions for creating entanglement. Date August 30th. 2023. Source: University of Innsbruck. Quantum physics has allowed for the creation of sensors far surpassing the precision of classical devices. Now several new studies show that the precision of these quantum sensors can be significantly improved using entanglement produced by finite range interactions. The researchers were able to demonstrate this enhancement using entangled ion chains with up to 51 particles. Meteorological institutions around the world administer hour time using atomic clocks based on the natural oscillations of atoms. These clocks pivotal for applications like satellite, navigation, or data transfer have recently been improved by using ever higher oscillation frequencies in optical atomic clocks. Observations of quantum systems are always subject to a certain statistical uncertainty. This is due to the nature of the quantum world. Entanglement can help us reduce these errors. The researchers use lasers that tune the interaction of ions lined up in a vacuum chamber and entangle them. The interaction between neighboring particles decreases with the distance between the particles. Therefore, they use spin exchange interactions to allow the system to behave more collectively. The small particles in the chain were entangled with each other and produced a so-called squeeze quantum state. Using this, the physicists were able to show that measurement errors can be roughly halved by entangling 51 ions in relation to individual particles. Previously, entanglement-enhanced sensing mainly relied on infinite interactions, limiting its applicability to only certain quantum platforms. And with their experiments, the quantum physicists were able to show that quantum entanglement makes sensors even more sensitive. They used an optical transition in their experiments that is also employed in atomic clocks. This technology can improve areas where atomic clocks are currently used, such as satellite-based navigation or data transfer. Moreover, these advanced clocks can open new possibilities in pursuits like the search for dark matter or the determination of time variations of fundamental constants. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.